Okay, so we were continuing here. We were talking about the sensors and how this particular machine operates. There's actually four categories. I can't reiterate enough, what we're talking about here. Reflective sensor, hopper, this is the start sensor. And then there are 2 count sensors that will make determinations of the bill being a half or being double. We'll talk about that later on. And then the stacker sensor. But the most important sensor on here is always the one that is hidden from the ability of you cleaning this machine from the front. It's on the side right here. And all logical devices that are using some sort of mechanical wheels and things of that nature have to have a device, an encoder, to time itself. You might ask yourself, well, I got a clock besides my bedroom. That's a logical device and it keeps pretty good time, but there's nothing in there that's mechanical. Well, that's true, but basically a clock is only demonstrating keeping time. There's actually a timer inside that called a flip-flop that basically does this electronic timing, but it's not coordinating mechanical devices as these things process. So if you look over here on the side, which is the mechanical side, there is a sensor right here. We call this a U sensor, or you can call it a flag sensor. There's many different sort of little nicknames that we give these things. But this sensor, basically, it shines through, and there's a wheel right here that has holes in it. And then as the light shines through that hole, there's actually a timing that's being created. And if you actually put an oscilloscope on this, back in the old days, we did stuff like this, you would see a square wave being generated. So there's a consistent pulse, no matter what the load is on the machine, whether you're having a heavy load that's burdening the wheels spinning, or maybe the voltage is a little bit different. But basically, this thing times the entire machine. So it's important that this encoder is actually clean. One thing you don't want to do is ever break this thing. You might want to make sure that you take the can of air and you blow out the little holes, or you take a brush or something and clean the holes out. Make sure you don't leave a piece of the brush in the hole. You can actually look at this on an oscilloscope. It generates this beautiful, cool little square wave, when it's nice and clean. But when it's dirty, it basically generates a little hump kind of wave. So what's happening is the transition from on and off is not completing its particular timing cycle. So that could definitely cause you some problems. This right here is another reversing or one-way bearing right here. And what happens is this thing is allowed to spin after the main motor is generating the counting process. So this is all spinning. So what happens is when it's done counting and is stopping for the batch, this is allowed to coast on to the end. And this is basically the stacker part of it that's actually coasting. So that is how the mechanics of this works. So we'll kind of go over again a little bit about how the mechanics work stripping the bills apart. So I have a deck of cards here. So if you think about money, as you put the money inside the machine, this kick roller, there's many things you can call it, feed roller, advancing roller, whatever, it's trying to thump the bottom bill off the bottom. And so the reversing roller is thumping the stack to the back. So it's fanning the money backwards until it goes into the machine. Now, just keep in mind, these are your basic money counting device. So there's really only I think there's 4, I'll have to correct myself when we're doing this live, but the 2 main errors that you have in one of these devices is double, one on top of another, and then linked together as a chain. We'll talk about the others in the next video.